Nodal analysis. The problem is to determine the nodal equations for each node in the circuit. Whenever we're doing nodal analysis, we always start with identifying the nodes in the circuit. And we know that we have a node at the upper left-hand side of the circuit. We'll call it node 1. We have a node at the upper right-hand side of the circuit. We'll call it node 2. We also have the ground node at the bottom, which we know is at 0 volts. Associated with the circuit. So we have node 1, node 2, and the ground node at 0 volts. So we're going to use nodal analysis and Kirchhoff's current law to write the equations about node 1 and node 2. Ultimately, what we get from nodal analysis is the nodal voltages. So we'll find through our series of equations the nodal voltage for node 1 and the nodal voltage for node 2. Knowing those two nodal voltages will give us the ability to solve for any other elements or any other quantities in the circuit, all currents and all voltages. So we're going to use Kirchhoff's current law, and we're going to sum the currents into node 1 and node 2. Starting with node 1, we have the current I sub A, which is flowing into node 1, so we have I sub A. We also have the current flowing through R1, so the current's flowing from the ground node up to node 1. That's going to be ground node, which is 0 volts, minus the voltage at node 1, V sub 1, divided by R1. We also have the current which is flowing through R2 at the top of the circuit associated with node 1. That current is going to be V2 minus V1 divided by R2, and that's equal to 0. So we can take a look at that equation, and we notice that we have two unknowns, our nodal voltage V1 and our nodal voltage V sub 2. The other quantities, the resistances and the current source, would be given to us in a problem. So that's our first equation. We then move to node 2 and we look at the nodal voltages. We write the equation which ultimately will allow us to determine the nodal voltages at node 1 and node 2. It's our second independent equation. Again, summing the currents into node 2, we have minus I sub B, because it's in fact a current source flowing out of node 2. We have the current through R2, which is going to be V1 minus V2 over R2, flowing left to right through element R2. And we also have the voltage, or the current, flowing up through R sub 3, which is going to be the ground node, 0, minus V2 over R3, and that's all of our currents flowing into node 2. We see that we have two unknowns in that equation as well, V1 and V2. So now we have a series of equations where we have two equations and two unknowns, and we can solve those equations simultaneously to find V1 and V2.